All right, welcome back. We are Game 2007. That's Multiplayer Game Design 1 in the winter 2026 semester at Georgian, and it's week 4, part 2 of our broadcast and recording. In the last one, we talked about assignment 2. So if you're looking for details around that, please see the previous video. On this one, I just want to kind of go back to our schedule. So again, lots of stuff that we've done with working with our project from so far, multiplayer, and we're going to add things to the HUD. That's what we're going to be doing. And again, one thing that we're going to see today is a few items, pickups, and so on, and I'm going to talk about what those things are. So we're going to be talking about the thing that you need for assignment 1, which is replicating properties over the network and how to do that. It's fairly straightforward, but I want to go over it with you, and there's some things that I want to kind of do with you. One thing I should probably do before people start going, where's that PowerPoint? You're going too fast. I should probably kick off that stuff and make everything available to you. Sorry, I had a bit of a technical issue earlier, and that is resolved, but doesn't mean that I can't make this stuff available to you, which now it is. So that's week 4. It should be available, and also I should make assignment 2 visible as well. There you go. So that should be those 2 items. So again, I want to create character stats. I want to show you a way of doing that, which is different than what we've done so far together. I'm going to be using structs and data tables. Some people have been using that. I noticed that a couple of people are delving into that for their own game. That's good. You should. There's some really cool things that you can do with those, and we'll start talking about one thing. We'll handle character level ups, like how to get experience and all that kind of stuff with your character. We'll create a base pickup, and we'll create 2 other child pickups, a gold coin and a silver coin. That's what we'll be doing. So again, assignment 1 is now due Tuesday. That thing has been moved, and again, I'm supporting Global Game Jam for that. Assignment 2 has been released. We just talked about that. So what I want to start doing right now is adding character stats, but before we get into that, I want to kick off my project. So I'm going to go into here, and I had week 3 from last week. This is that week. I'm just going to copy paste it and to create week 4. I've already made a week 4 completed, and I did that because I wanted to make sure that all the previous code still works, and it does. With some minor tweaks. I had to do a few tweaks for the previous time I've done this one, so I wanted to make sure that it was working properly, and that's what I kind of always do for the most part. Just going to kill this Git repository because we're going to make a new one, and I'll start off with that now. So just like we did before, I'm just going to do a git init git add dot. And this should be all memorized by now. Git commit -m, initial commit. We've done this a bunch of times over the last little while. And git branch -M main. So if you don't know how to do this already and you're still struggling with DevOps at this point in time, I mean, we've been doing it for a while, right? So it's something that I think you guys should be pretty good with. If you're still not good with DevOps or having issues, I know some people might be having weird issues with DevOps, you got to make some time with me, guys. And you can do that by booking time, like we normally do. You can book time for other things too if it's not that's your issue. If you do have other problems or questions for you and your partner for this for this semester, please, I'm here to support you. So if you have a problem, please book time. All right, there we go. Sorry, my mic's in the way. Okay. And that is our start for week 4. Luckily, this is not a big project, so it doesn't take that long to upload. There are some large file objects, but there's not that many. And I'll talk about a couple of things of the project in a second. There we go. So that's up. So that's your week 4 start. And then what I want to do is, again, if you want to follow along, you know, I've given you the repositories there so you can follow along. There's no mandatory need for you to do it. Like, I'm not forcing you to follow along. Again, it's not in-class exercise stuff, but I do want you guys to try your best to stay with it. There's quite a few details, and if you practice, then when it comes to your exam, which is a few short weeks away, then you'll be better at it. Like I said, and quicker, as opposed to, you know, like trying to figure things out during the exam, and that's bad, right? So please don't do that. Please follow along as best you can. At least practice what I've given you so that you're not caught flat-footed on the exam. Okay, I'm just going to double-click here to start off week 4. Last week, what I did was I asked you guys to finish the animation piece. That was the last part that I asked you to do. It's not that bad, but many of you would have noticed, if you actually finished that piece, that replication is pretty good with some basic animation. You know, when we kind of put together our animation blueprint and all that stuff and our blend space. So that's something that we were doing last week, and it should work just fine. And I'll show you why, for the most part. Now, there are other things when you activate an animation, like for example, we haven't done the jump animation yet, and other things like that. You'll see that requires a little bit, you know, kind of some differences, especially if you're changing animation states. You know, but for the most part, it should work just fine. Midterm is going to be formatted similar to what we've done before. It'll be in person only right now. Again, pending any kind of weird weather effects or whatever. You know, the plan is to be in person to do it. You'll have, I'll try and meter it for 2 hours, so it's not going to kill you in terms of time. And then, you know, you're going to be given the same project you've been working with the entire time, and I'll get you to do something we haven't done in class, which is very similar to what we've already done. So, you know, adding on to this kind of the stuff that we've already talked about, you know, so again, and this is for each of the exams. Same thing. You get your starter project. The starter project is based on the stuff we've been doing throughout the semester so far, and then you move on. It's all practical. So I'm not going to like kill you with theory. I don't do that. And then again, when it comes to your work, you'll be working alone because it's an exam. So that's where it's a little different. You know, maybe right now you're working with a partner because you're working on your project, but exam is an exam, so it's a little bit different. All right, so now that I have our project up, let me just make it so that, there you go. Just gotta swing it back here again. And I always want to try and test it out. We know that it's a multiplayer project and there's 2 players. That's important. Net mode should be set as listen server at this point, and we should press play. And then once we do, we'll have you know, this stuff happening. So right now, you can see that they are in idle state. There we are. And so this is my main character. They're running away. Yay, right? And then if I switch to my second character, then they also can run, and they also have an idle. And the main thing is, can my server see both? You can see that they can see the idle animation. And then the other thing is, can my you know, can this one see my server animations? And you can see that the animations for my server character are always also working as well. So this is an important, you know, factor, right? So here's my server's red. You can see that the animation, if I go close, is working, the idle animation, which is pretty cool. So how did I do it? And I just followed along with the PowerPoint is what I did. But I want to talk about the process. So first, we were asked to make a blend space from the PowerPoint last week. Again, this is just going with the homework that I gave you. So here's the blend space. Again, there's a couple of points that we added in. We made the horizontal axis named speed. We changed the maximum axis value to 500. And then we pulled in certain animations here that were compatible with the character. That's what we did. Okay, so that's major blend space. For the most part, blend spaces are very useful when it comes to something like this. Then we made an animation blueprint, and this one doesn't have a state machine. It only has this right now. We will change this to a state machine later. What we did was in the event graph, we have two events. One of them is the initialize animation, which is kind of like a event, begin play equivalent for the animation blueprint, right? And then we have the update animation event here as well. The initialize animation, what it does is it just sets up two things, the character and the movement component as variables. And then from there, the event blueprint update animation, what it does, it takes the movement component and gets the velocity every frame, and then gets the length of the velocity, so how fast the person's moving, and we're just converting that into a character speed. You could also call this ground speed or just speed. And then once we have the speed, we can use it in the anim graph, alongside with your blend space. Notice the blend space only has one input, and the way I did that was I went to, on the right side here, and you can bind or unbind pins. So I can expose pins or not. And what I've done is because the second axis, I'm not using it, right? So I'm not using direction as an example, then I just unbound it so you only see one axis here. And you can see the representation of the graph that's right here when it comes to the blend space. Goes to the default slot and goes to the output pose, and that's all it was for the animation blueprint. Once the animation blueprint's done, then of course we'd go into the character blueprint. So here's the character blueprint. And I'm just going to close this off. And if I look at the mesh, all I've done is I've used the animation blueprint here. And because the animation blueprint is, kind of something that replicates by default, then you can see the animations that are there. Now, in terms of activating certain montages and that kind of stuff, that's where we're going to have to use, kind of the whole networking thing that we've been doing before. Some kind of RPC, remote procedure call, rep notify typically, or something like that we use to activate the animations. But if you're just playing an animation in the animation blueprint, it's not a problem. Both players will be able to see that. So that was last week's homework. And now what I want to do is I want to add character stats. So again, property replication is what this thing is all about. And the good thing about doing it this way is you kind of kill a couple birds with one stone. So one thing that we want to do is we want to create a certain amount of stats like we would if we were playing like a little role-playing game, right? Or some kind of action adventure game or whatever, right? And so what we want to do is we want to be able to set up a struct. Okay, that's where I want to start off with first. I think it's a good way of doing it. So again, what I want to do is I want to make a folder named structures. So I'm going to go out here and just outside of blueprints, I'm going to make a brand new folder called structures. Inside the structures, I want to go make a blueprint, and it's going to be a structure, or a struct, as we like to say, struct. And then this is going to be a blueprint structure, a BPS, and then underneath, I'm going to call this the character stats. And for the character stats, what we have is a bunch of different stats that we want to keep track of. Walk speed, sprint speed. When the character levels up, we want to increase the speed of the character. A damage multiplier when they do damage to enemies. That'll continue to scale, as well as what's the next level XP. What is that? Kind of like the number that you need to achieve to get your XP. And then stealth multiplier and so on. So this is all stuff that we can scale. Now there's a couple ways to do this, by the way, later on, but first we start off with the struct. So walk speed would be the first thing, so I'm going to put here walk speed, and then the type, just like we've done before in the past, so that's float, and then the default value you can set at the back, which is 200. So you just flip the tab here to do that. Same thing with the next one, so sprint speed, so you add another value, sprint speed, and then the default value for sprint speed being 400. So these are fairly low values to start off, as an example, and so that they're going to actually make us slower in the beginning than we are right now. Damage multiplier. Now there are different ways to set up a struct. You can set them up like this, like how I'm setting it up right now, and fairly manual. And there's other ways of doing it as well. But this is the kind of the way we do this in Blueprints. You can also set up a struct in as well in C++, like we've seen before. And then what we can do with that is we can kind of expose that struct, and you would see it. Now you wouldn't have the same direct access as you do here to set up the default values, but it works the exact same way, and we've seen that in the previous course we did together. So that's what we did. And then the last one is stealth multiplier. So now that we've set up our struct and we set up our default values here, this is going to be the basis. So save that. This is going to be the basis for what we're going to be doing with our data table. So I'll talk about that in a second, but a data table is neat, and I want to look at the documentation 1 second with you because I think it's kind of an interesting thing to look at together. So one thing to do when it comes to data tables is you can import from Excel. So that's one thing that you can do. So you can make a data table in Excel, and then and this is really useful, guys, like super useful. And then what will happen is you can make it so that Unreal Engine kind of imports that file, which is great, and then we'll use that. So why is this really good? I mean, I'll tell you right now, whenever I'm making a game, or whatever it's going to be, I have data tables for everything. And a good example is the game I'm currently making. I make a lot of the weapons, the stats for the weapons, and all that kind of stuff in Excel first. Before I share that on the web or put it on a database or anything like that, it's Excel. And it's really super easy because it creates almost like the same kind of idea, a data table. You can add things like the damage that you do, initiative, if you have some speed for the weapon, weight for the weapon, all kinds of stuff, cost, whatever it is. You can put all that stuff on the weapon itself. So whether it's a weapon that you have or whether it's character stats or whatever, it's really simple. Now there are two ways of doing this data table stuff. One way is again a CSV file that you can do. You can also make an Excel file, and then what you would do is you would load it up. You can do this in both C++ as well as Blueprints. But basically what it looks like, a CSV document is a comma separated file that might look like this, and it comes right from Excel. And you can see that the first column, or the first row I mean, is the header row, and the header row basically talks about each of the field names. So again, name would be the field name, XP total, additional HP, achievement icon. All those are field names or properties, and then the data for all those in column format underneath that, which is pretty cool. Okay, so that is a way of doing it as well. You can put it in CSV format and then load it in, as opposed to doing what we're going to do in a second, which is manual. Okay. The other thing that you can do is when you import, you can import it as a couple ways. One, you can make a data table, based on a struct, like we're going to do. And the other thing that you can do is you can make something called a curve table. And a curve table is interesting because it kind of does things like if you're going to have a level curve or whatever, that's also something that you can do. For example, here they give you kind of a demo of a curve table that's related to leveling, right? So when you level up, there's basically these. I mean, unlike gotta go back to Elden Ring. Unlike the caps that happen every 20 levels or whatever it is in Elden Ring, you have these numbers, and it creates almost like a graph. If you actually look at the data curves here, and you can actually graph out what your table would look like, which is pretty cool. So this is like, it shows you the curves, and which is really great from an analysis perspective. The great thing about data tables, and again, I highly recommend you do this kind of stuff, guys, to set things up for weapons and all this kind of stuff, is it creates game balance. What you can do is you can test, you can look at the each individual weapon and really classify them in terms of DPS and all this other stuff by looking at the data table themselves. Like how much damage they do over time, how do they scale, do they scale at all, that kind of stuff. And typically what I've noticed with most game is like things like AoE attacks that are also ranged and that kind of stuff are favorable, especially later on or mid-game to late game, as compared to things like single melee attacks. Ranged attacks clearly are a lot better, easier to to kind of use for many games and that kind of stuff. Whereas when you're in close, when you're in a melee combat or something like that, if you're playing that kind of game, then you're putting yourself at risk because then you're right next to the enemy. So so this helps you understand all that stuff, and it actually gives you some data that you can feed out back to Excel if you really want to as well. So you can do that kind of thing. So really interesting stuff. Highly recommend you take a look at it. I've given you the link for the documentation here. But so what we want to do, I'm just going to close this off. What we want to do is kind of make a data table. Okay, so that's one of the things we want to do, and you can find that in the miscellaneous, kind of menu. So if I go back to here, I'm going to right-click and I'm going to go to miscellaneous. Here it is, and you can see there's a bunch of really cool things here. So there's a curve table. That's something that I can do. So an imported spreadsheet table has curves. So if I kind of click on that as an example, it tells you the kind of curve that you have, whether it's linear or constant or cubic or whatever kind of curve you have. Let's say linear, and then you can create a curve table from there, and then you can import the data from Excel. That's one way of doing it. The other way to do it is, if I go to miscellaneous, what we're going to do today is we're just going to make a flat data table, which is used for things like stats and that kind of thing. Again, that could also be a curve table, but this is pretty cool. So when you make a data table, you must pick a struct. So you can pick one that already exists as an example, or in our case, we're gonna pick this one here, which is BPS character stats, the one we just made, and press OK. So then we're going to call this DT for data table, and then character stats. So that's the first thing. So character stats are there. Double click, which brings up our data table. So it doesn't look like much right now, but what we want to do is we want to click on add. So if I click add, then you can see it adds a row, and this row is based on the default values that we put in our struct. Okay, that's what it is. What we can do here is we can right click and we can rename the row, so we can call this something like level 1. Okay, so level 01, and then we can kind of spread these out so we can see each of these values. So you can see each of these are just like how it would appear in an Excel spreadsheet. Okay, kind of like this. And then what we want to do is, this is not enough. We want to make 5 of them. So a quick way to do it, you can add them manually like yourself if you wanted to, or you can right click and then you can just go duplicate and then just modify this. So if I was say like level 2, what would that look like? You want to modify these values. So the way you do that is here, and I've given you some values to add. So 250, 800 for level 1. So 250, 800, and then it's 110, 1. That's for level 1. Level 2, that's going to be, and that's why it's good to duplicate the one we just had, because I'm going to put them in there, but 275 and so on. And just, you can put them in any way you like, but I've given you the numbers on the PowerPoint. So if you like to, 1.1 for the damage multiplier, so a little bit more damage and so on. And then next level XP is 25, so a bit more XP. As you can see, there's a bit of kind of a linear curve. And again, I'm going to right click and duplicate again and rename, right click and rename to level 3. There we go. And then again, it's 300, 900. So the person gets faster. Again, not always, this isn't exactly realistic. Maybe you don't want to, increase speed and that kind of stuff every single time, like walk speed. That's kind of a weird thing, a weird metric to increase. Maybe you want to have walk speed increased by some kind of item that you're carrying, or the armor that how much armor you're wearing and stuff like that as well. But in this case, this is just an example of what we can do, right? So that's why we're putting it in here. So now we're doing level 4. Again, right click and duplicate, and right click and rename, and we're going to call this level 4. And again, if you're a data person like me, like someone who likes numbers, then this kind of thing will totally speak to you, because it'll give you the opportunity to, kind of make this, workable. Did I make this right? 2.5, yeah. Did I do that right? 1.3950, 1.3100, yeah. Okay, and then one more. So duplicate, and then we'll rename this to level 5, and then it'll be 350 starting off. So it goes up by about 350 every time, 1,000. But again, it really depends on how you want to scale your stuff. So this is a really great way of doing things, and I highly encourage you guys to, wow, that's a lot, 200 XP, so double the XP, and 3. One thing that you know, we talk about when it comes to XP and leveling in general is micro leveling is a good thing. You know, so even if it's something that you can give your character, your player, doesn't matter which game, whether it's an ability, slight increase in damage, the ability for them to move a little bit faster, you know, carry more stuff, whatever it is, even if they're not leveling up as a whole, like maybe they don't level up, but they gain items and armor and all that kind of stuff, that also really makes it so that they feel like they're progressing. Because progression is not just necessarily level, it's also other stuff, right? So, and it really depends on the game. Sometimes the stuff is more important than the level. Like, for example, you might have a low-level character that managed to find a secret room or something, and then they found a really cool item, and that can help them, you know, get along in the game and do more damage and then collect more experience, right? Or some kind of experience token that gives you more experience over the time. So that's your data table and your struct. So those are the two things that are related to each other. Once we have these two things and we have the data table, now what we want to do is we want to include that in our character. So I'm going to go back to blueprints, and here's my character again, and I want to add those two things in. You know, so the first thing I want to do is I want to make a variable called character data table. And it's going to be of type, you know, data table object reference. Let's do that first. So I'm going to do that. The first thing I'm going to do is I'm going to variable, so data table, and then it's going to be data table object reference. It's not going to be that specific data table. It's going to be just that. And the reason why you want that is compile and save. Then you can select the data table we just made. So that's the first thing we do. So compile and save, and that's based again on our struct that we're using right now. That's available to us. So that's the thing. So that's using DT character stats. The other thing we want to do is we want to make character stats, which is of type this struct. So again, make a new thing called character stats, and this time it's going to be based on BPS underscore character stats. Notice that there isn't a object reference because a struct is not an object. It's a value type kind of. Even here in Unreal Engine, although it is like a class, they're treating a struct like a value type, which is pretty cool. It's like a custom data type, and it's different than how you would normally use a class or something else like that. Okay, so that, or a blueprint. So that is what we have. Now, one thing that we want to do is, because if we change our character stats, we can change that. We can't change our data table. Our data table is fixed. That's kind of like a little database, you know, kind of like in the app that allows us to understand what the next thing is going to be, right? One thing also that we can use the data table for is, instead of using if-else statements, if it's less than this and greater than that, as an example, then do this. We can have a data table for that, which is a lookup table, right? So my level is 1, or my rating is this in my weapon, and then, you know, I'm going to get this bonus and that bonus and the other bonus, and that's based on the data table, as opposed to, you know, you hard coding that, right? Great thing about data tables is it allows you to be flexible. If I want to change my data table, my existing code will adapt to what my data table, what the data is that's in my data table. But here, what I want to do with my character stats, when I change character stats, we talked about this last time, because I want to replicate this over the network, and this is how you do replicated properties, we want to rep notify. Okay, so Again, what I want to do is character stats on the right. You can see that we can put rep notify, and once we've done that, now it creates a function on rep character stats, which is kind of similar to what we did with skin material, which allows us to kind of replicate our character stats amongst all the players that we instantiate in the game. Okay, that's how it's going to work. So compile and save. So that's the first thing we do. And then once we've done this, then the next step is to actually have our kind of fashion out our on rep character stats. What happens when I change my character stats? Well, I want to change my max walk speed, because that's what's going to increase. We know that that's the case. So this is kind of a simple example of when something happens, when my character stats change, well, we want to respond to that and do something else. So that's what we're going to do. So we're going to make a brand new function. Actually, let me just undo that. We're going to use the function that's already there, this one. And then what I want to do with this is I want to pull in a reference to my character stats. There we are. Notice again the two spheres. I want to break that character stats struct, right? You can see that there's two, but there's actually a few other things that are here. These are all the properties from the struct. That's what they are, right? And then from there, I want to get character movement. So here's my character movement component. And then from there, I want to modify my walk speed. So you can say set max walk speed, right? Which is how we set up our run. And that walk speed is going to be based on the walk speed that we have from our character stats. So that's what happens there. Okay. So that is the on rep character stats. When any character stat changes, when our character stats change at all, then we increase our walk speed. Now you can do this. You can add a bunch of other outputs from here, and you can keep track of other stuff. For now, we're just keeping track of one item just to show you how this works for you. In your assignment 1, you've been given other things to keep track of, but this is the way that you would do this. Is the pattern that I recommend you use. Okay, whether you use a data struct or not, even if it's individual variables, right? You still have to do rep notify to do it properly. Okay, as you'll see. So then once we've done this, once we have our on rep character stats set up, then what we want to do is we want to create a new function called update character stats. So update character stats function, there it is. And update character stats, what it's going to do is going to take in a character level. So when the character level changes, we update the character stats. That's what really it is. We could have called this function something like, update character stats based on level. It's pretty long. So that's why character level is, we're going to add that in as an input. So character level. And all we want to make this as an integer, because the integer will change. If it's like a level 1, level 2, whatever. And then what we can do is we can take the character data table. So this is the data table itself. Here it is. And now we have a reference to the data. This is kind of really cool because we connected to it. What we want to make sure is that this is not empty. So there's two ways to do this. We could right click and convert it to a validated get. We've done this before. Or we can just say is valid, this function. That's another way of doing it. There's 3 ways, remember? And they do different things. We can branch here. And once we've done that now, we check to see that this is not empty, because what if you forgot to do this? You forgot to make a reference to the data table somehow. Then this could be a possibility that your stuff can crash. We don't want that to happen, so first we check to see if this is null. If it's not null, then we can do something. If it is null, we do nothing, right? So we don't update character stats if it doesn't exist, kind of thing. Then we can use a small sequence just to make it easier to read. And that sequence has 2 parts. One, character data table again. Hey, character data table. Here it is. And what I want to do with that is I want to get the data table row names. So get data table row names. So what this does, it gets all the rows in the table. So I just loaded the table up. Now, this is okay. And you might think that, this is fine. But I'm loading up that table every single time. Every single time I do an update to the stats, I load up that table. So there's other ways to do this. Can anyone suggest another way of doing this that might be, less brute force than this? We're doing it this way, but I want to talk about this so that you can think about other ways of doing this. So think about what I'm doing here. Every time I update my character stats, I check to see if the data table is available, and the first thing I do is load the data table. And this data table, what if it's 10,000 lines long or 100,000 lines long, right? That's going to be a bit of a delay when I update, when I level up, as an example, right? So positive doing about this is you get the latest data. If the data changes regularly, then this is okay to do, right? If it's a small amount of data, let's say like something that we have, like 5 levels, it's okay. You can do that every single time. But if it's thousands of items, and it's a lot of detail, you want to do that once. And you want to do that usually in a begin play or something like that, where, you know, once the begin play is done, you load your data table and you hold that data table in memory that you can use anytime you want. Okay, so that's how I would do it. Let's make this into a, so I want to promote this row names to a local variable. So again, promote this local variable. We'll call this row names. But what we could do, as I said before, is we could actually have this as a variable that I load up that's part of the blueprint itself, as opposed to a local variable that's here. So this is kind of what this does. We've just loaded our data table. And then the second thing I want to do is I want to use the character level to get the appropriate row from the data table and then set the character stats, which is pretty cool. So again, we can use character level. That's just the parameter that comes in from the function. And then just make this look nicer. And then once I've got that character level, I want to subtract 1 from it. So subtract 1. And the reason for this is because if my character level is 1, I want to look at row 0. Again, remember what this is. If I look at the data table for a second, here it is. Each of these rows, they're, you know, we're using zero-based counting. They're just arrays, right? That's what they are. So this is the 0th row, first row, second row, third row, fourth row. So if I'm level 1, I don't want to look at this. I don't want to look at the 1th row. I want to look at the 0th row, which means I want to subtract 1 from it. Okay, so that's why I'm subtracting 1 here, just like any array. And then row names, which is the array of basically the entire array of data, right? What I want to do here is I want to get, and I want to get the row from that data. So the first row in this case, you know, whatever it is, or whatever the character level is. If it's row 2, if it's row 2, then it's character level 3. As an example, subtracts 1, and you get that number. Once I've got that row, then we want to use the character data table again. All right, here's the character data table. And what I want to do is I want to get the data table row from the table. So I want to get data table row, this one. So again, I mean, I've saved the row names, and this is the whole all the data, and then I want to get this, right, based on the row name that I'm looking for. So basically, this gives me the row name. So this could be like table like level 01. That's what it'll give me. And then this function right here, it hunts or searches for that row name in the data, right? So even though we've saved this thing, you know, we've loaded it a bunch of times, you can see that, like I said, getting a reference to the data table itself, which we already have, is okay, but using this function here, we're doing it this way, so that we're going to get the row name, and that's why it says row name, and then we're kind of starting off like this. There are other ways of doing it. If I look at get data table, so if I go to this, let's pull this in again, just to explore, right? And if I go get, there's asset data, you know, there's a bunch of other stuff here, but you can take a look. There are quite a few things. Get data table column as a string, you know, get data table column names. That's the properties. Those are all the properties themselves if you want that. Get the table, get data table row struct. So the whole thing as a struct if you really want to do that, and it gives you the row number, so 0, 1, 2. So if I do this, then it gives me the struct. I can break the struct if I want to. That's what that is. Actually, if I just right click and if I just show execution pins, you can see that I can have that as well if I want to. But that's kind of what you can do. There's lots of things you can do here with the data table but all we care about is this. We just care about the row that we're hunting for, which is level 1, level 2, whatever the level is going to be called. If the row is found, so this does a search function. If the row is found, then do something. Otherwise, do something else. So, and this does two things, right? It gives us back the row if we found it. That's what this does. And the second thing is it's kind of a built-in branch. So it's a built-in if statement. So it's kind of a really helpful little function that this allows us to to do. So it's kind of really cool. That it allows us to do that kind of stuff. Okay, so that's what this is. So if the row is found, then what I want to do is I want to set the character stats. So if I go character stats and set, notice it becomes with notify. That means when I set the character stats, the rep notify function is triggered. That's if the row is found. And then I can take out the row. The out row is the type of data, the struct type. And because the character stats is the same struct type, then I can just link those together. Okay, and that is basically what we want to do when we update our character stats. And we do this based on the new level, the new character level that we're getting in. So let's compile and save. Okay, that's how we deal with using the data table at the same time as we kind of update our stats. So now that we've done that, we want to update our stats and make us level 1. And this is a good test for us. And I want to try this out now to show you what this looks like. So let's do that. Let's make ourselves level 1. And we can do that by going to the event graph. Here's the event graph. And I can scroll up to our event begin play. We had some stats that kept showing up in terms of printing out our role. And we also printed out our ID. I'm going to stop doing that now because we know what those do. So we can get rid of this. That was from the last few weeks. And now what I want to do is I want to update character stats. I want to do that. And let's update it for level 1. So put level 1 in there and compile and save. And then we can test this out. So if I was to test this out and see how this works, if I press play, we don't see the annoying messages anymore. If I look at the two characters, so again, I'm going to go here to MP character 0. MP character 0 seems to be this blue character, right? So here's the the blue character, which is this one. That's MP character 0. I know this because the camera, which is this camera right here, is focused on this blue character. That's the middle one. If I go to MP character 1, you can see the camera now is focused on this character over here. So we know that when I look at my, if I just click away here, if we look at our server, client server machine, which is this one, the main one, that this is character 1. That's what it is, okay, by default. So because of that, if I looked at character 1, I'm looking at my main character, and then what I can do is if I type in character, because we know it's called character stats, you can see that it's 250, 800, 1, 10, and 1. 250 and 800 is level 1 stats. And we can tell by, if I open up my data table, you can see that 250, 800, and 1 is level 1 stats. And we did that for both characters. And the way to check that, of course, is during play, we can look at the other character. If I go to level 0, this one, you can see that the stats are the exact same. So both stats have been replicated. Yay. Okay? And that's pretty cool. Now we need to know, can they change? That's the next thing that we're going to do. But for now, what we're going to do is we're going to stop this and we're going to put this up on DevOps. So let's make sure that we save all. File, save all. And we're going to do git add dot, git commit -m. And we're going to say added character stats. There we go. Okay. So now that we've done that, and we know that this is, good start, that's our initialization. We initialize our character at level 1, and the reason why we started them at level 0 and went to level 1 is to make sure that we can go from level 0 to level 1. Even though there's really no difference, we put those numbers in as testing numbers. So the initial numbers that we put in our struct, it was a way for us to check to see if we're able to update from one level to the next. Next, I want to update our our walking now, because our walking used some really weird things before. So we can look at the sprint multicast and the stop sprinting multicast that we did last week. So if I was to go there and look here, if I zoom out again, you can see that that is down in here. And instead of me doing it this way, these are hard-coded values, 3,000 and 600. We want to use our character stats. So one way to do that is just to reorganize this. And again, you could also do this in their own little functions if you really wanted to. I probably would if I was doing C++. Maybe little functions that say like, sprint and stop sprinting, whatever that might be, an actual function to do that, right? And so now that we have character movement, I also want to take our character stats here. So character stats, there we go. And then once I've got my character stats, I want to break the character stats up. And I have 2 parts, right? So if I'm sprinting, then my walk speed is going to be my sprint speed. So that's whatever that is, okay? And if I'm walking, let's put that down here, back to not sprinting anymore, then my walk speed is going to be my walk speed. So that's what this is going to be, okay? And that's what happens there, okay? So it's pretty good. Now there is something else we should do, right? Which is, so what ends up happening is, as soon as we level up, right, and I press on the walk speed, question for you, am I already walking at the right speed or not? That's the question you have to ask. And how is this determined? So if I just do this, alone, and if I was to be level 1, am I walking any slower? And the answer is yeah. Look, you can see now that I'm walking much slower than before. If I run, I'm not running as fast. You should also test to see if my second character is moving and being affected by that, and you can see that they are. So very slow. So walking is slow, and then running is also much slower. Okay, and that is because this has taken effect. This idea of my walk speed and everything else has gone in there. Even if I'm just walking, it's already kind of come into effect. Okay, which is pretty cool. So this is already good. We can test it out, and we know that it's working. Let's talk about leveling up. So how do we level up? Right now, we don't have a mechanism yet to level up, but we're going to handle what it's going to be like to level up. So one thing that we want to do is talk about where to put all that information. And you might feel it's really weird, but there is something called the player state class. Let's go over the mode, the game mode one more time. So the game mode is actually gives us a lot of information about all the things that get loaded, kind of at when the game starts, right? So if I go to the game mode here, which is in the blueprints folder, right? And if you look here on the right, there's all this stuff. These are all the classes that get instantiated, as an example, when my game starts. So again, we have a game session. There's the game state. There's the player controller. We've made some, kind of stuff with the player controller already. And there's the player state class as well. So that's player state and game state. Those are 2 different things, right? Player state is replicated for each player. So every player has their own player state. And that's kind of cool. That's a kind of a really great place to keep everything, as opposed to on the pawn themselves. So the pawn, again, it might seem counterintuitive to not put it part of the default pawn class. You could, but that would be tightly coupled, as opposed to keeping it separate and put it inside the player state. So player state is what we're going to use because this is where it belongs. Okay. There's other things in here that we won't handle, this week, but there are a bunch of stuff in here that is something that the game mode sets up for us. So back to this. So now that we know that we're going to use the player state, what we want to do is understand why it's used, right? So it keeps all this information, important information about our character. So when we think about this in terms of replication, that as soon as a new player is going to come into effect, once a player is instantiated into the game, they come with their own player state, which is pretty cool, right? And so that way, that's a great place to separate concerns and put stuff inside the player state. That's something that both players are going to use. Okay, so that's what we're going to do. So let's make the new player state blueprint. We'll call this BP_MP player state, MP for multiplayer. right? So let's do that. And the way to do that, and again, we want to, in the blueprint folder itself, like right here is where we want to put it. So I want to make a new blueprint class. And notice that there isn't player state by default here. So we're going to hunt for it. So if I type in player state, it's right here, right? So we can hunt for that special class. We can call that BP_MP player state. And if I look at it, it has its own, component section. Here's the component section that it has functions, it has variables. In many ways, it extends. It's almost like a component, a massive component that is something that the player has access to. That's not part of necessarily the player class. So it's not something that's getting inherited, but actually activated. So it's like I'm composing my character. So composition instead of inheritance. I'm composing my character based on, it having an associated player state, an associated player controller, an associated game state, and so on. Right? Those are all things that it has. So this is a great place to put all that stuff. So once we've created that and we've made our player state and we've kind of added it into the game mode, which is what we want to do now. So if I go back to the game mode just for a second, we just added in a player state. Let's activate it. So here's my player state class. We can just type in BP_MP player state right there. So now when the game mode starts, we have our custom player state that comes in as opposed to the default one that Unreal Engine creates for you, which does nothing. It's like empty. And then what we want to do is have two variables, one that's called XP, which is of type integer. So let's do that. So variables in the player state. We can get just lower down the player. I like to kind of close down some stuff so we don't get confused. So player state XP, it's going to be of type integer. As an example, the category that we're going to put it into is experience. So we're going to say category experience. Another category we could have used is advancement, because we want to, kind of how a character advances or progression. Another one that we could have used. They're all good. From a replication perspective, how do we replicate this property? Well, so there's two ways of doing that. Is it a rep notify, or not? And yes, because it's a property that we want to replicate per player, then we're going to have its own rep notify. The other thing that it's going to have, which is special, is that it's the owner only. So every owner has their own set of it. That's something that's important as well. That means that's down here, this replication condition, which is something we really haven't talked about yet. And if I open up this menu, you can see there's a lot of different options here. So for example, one of them is owner only, another one is initial only, skip owner, and so on. Every one of these is interesting. It has its own little effects. We're going to go through them. But for today, know that we're going to use owner only, so that only the owner gets a copy of, their own game state or player state. So it's not replicated, like the same player state is not replicated for each owner, as an example, which is a broadcast that goes everywhere. We don't want that. So only the owner is the one that's going to get it. And that's XP, okay? The XP default value should be 0 because we don't have any default value. And that's pretty much all the stuff for XP. Let's do the next one for character level. That's another one. It's still an integer because it's not like you can go level 1.2 in this game. So again, integer character level. We're going to say the category is the same. So experience, we can pull it down now like we've done before. Replicated is rep notify. And again, replication condition is owner only. Compile and save. And character level by default is 1. All right, so that's the other thing that we want to say. It's level 1. You're not starting off at level 0 character. Some games, though, they might want you to start at level 0. I know some killer DMs want to start off at a character, in a campaign that's like really low, and they want to start you off before you even level 1, kind of thing. So that is the way it's done. By the way, I've seen other games the other way around. You start off at level 10, you lose all your levels, and you go back to level 1. Games like some Star Wars games that I've played start off like that. You start off and you have all your power, and then afterwards you get nothing. You got to learn all that throughout the entire game, right? So it's kind of cool to give you a preview of what the game could be like. So then once we've got our those functions, what we want to do is we want to add something new, okay? And I want to talk about this again through documentation. let's look at the documentation. So there's something called dispatchers, event dispatchers. I like to think of these things as delegates. So in the world of programming, a delegate is like, if I have an arrow function or an anonymous function, instead of having a named function, and we do this a lot in JavaScript and basically event-driven programming languages like that, and same thing with C++ and as well as in C#. So it's a lambda expression typically, and the lambda expression points to a function that is unnamed, right? And yet we want to associate that function, that unnamed function, with an actual named function. We want to bind it to something else, right? And so we can use a delegate in programming, but we don't have delegates necessarily in Unreal Engine. So how do we cope with that in Blueprints? We use something called dispatchers, which are kind of the same thing. So really what an event dispatcher is it allows us to bind and unbind events. I can create an event, almost like a listener, and I can do that, a manual, almost like event handling, if you will, or listening for something to change by creating my dispatcher by, manually. And I'll show you how to do that. So what we want to create is two dispatchers, two delegates, if you will. One of them is called on XP changed, and the other one is on character level up. Let's do on XP changed first. So here's how we do it. We go down here, which an area that you haven't used yet. We're going to click on event dispatchers and add in this new name, on XP changed. Once we add this in, it's like, in many ways, it's its own little function, right? Without having a body. There's no function body for on XP changed. It's an event that we're creating, a named event, but it's really pointing at nothing right now. We have to bind it to an actual function in the future, almost like we're creating the function and what it might take. In this case, on the top right, the inputs look a little different. If you actually hover over, this is a little bit different than what it was before. And I think it's kind of like a remnant of what it used to be in previous versions of Unreal Engine. I think this may change eventually. Like up here, it might look more like a function. But right now, if you look at the top here, if you click this plus button, that's where you add in parameters. So if I click on plus, then you can add in a parameter, and the parameter that we want to add in is new XP. Okay, and new XP is what it's called. It's of type integer. That's important to make as well. So that's the integer type. And that is your event, your new event on XP change. The key thing when we make dispatchers or delegates, this ability for us to bind to some event that we're pointing to. We don't have an event yet. We're going to point to another event. That's what's happening, right? And you'll see why in a second. The idea here is our naming convention. On. Once we use the word on in front of it, it's almost like when. That's when I'm thinking about on. When this changes, then point to this and execute this function. That's what we're saying here, right? So on XP changed, which is what this is what's happening over here. That's what this new event is. On XP changed. Again, we're not pointing to anything yet. We also want to give this a category of events. Okay, we can make this so it's not just a dispatcher. We have its own. Even dispatchers can have their own category because they can have lots of dispatchers. I want to add another one, and the other one I want to do is I want to keep track of when the character levels up. So those two events, one of them is when the XP changes. I want to keep track of that, and the other one is when character levels up. Just like before, I want to click on a new parameter at the top here, and that new parameter is going to be called new level. Right there it is. And then we want to make that a part of the events category. So that's what it looks like. So that's right now, they don't do anything. We've just set up delegates that don't point to anything. They're not bound to any event. They don't do anything right now. Okay, that's key. That's a key learning here when it comes to this kind of stuff. And the reason for this is because it's almost like I've got these kind of a fancy name that I want to use on XP changed. I'm making my own event. I'm making almost like a custom event, if you will. But this custom event isn't going to be created now. It's going to be created when I need it. I don't know if that makes sense, okay? But that's what it is. And the reason for this is because of the nature of the asynchronous nature of multiplayer networking, okay? We don't know that, I don't need this event to be created all the time. And because I'm going to have multiple players, potentially, up to 8 or whatever it is, and here in this case for a listen server, I think I can have only 4. I want these events to be bound at runtime dynamically. Okay. All right, so that's what this thing is. Okay, and if you read more about it, there's more about dispatchers and delegates, and that's what they are down here. Next, now that we have those dispatchers, the next thing is I want to make my the ability for me to add XP. So if I pick up something, an item, or if I pick up treasure, or if I pick up whatever, or if I kill a monster, as an example, then I want to add XP. So this is the next function, and it's going to have a value, an integer parameter called value. How much of XP am I adding? So let's do that next. So again, I'm going to make a new function, and it's going to be called add XP with a value parameter. It's going to have a value, and it's going to be of type integer. So that's the first part of the function. Now, a nice sequence node is going to help us order our code. I'm going to add in a couple more execution pins here. And the first thing that I want to do is I want to say, okay, so I got this XP, my current XP, whatever that is, and I add in my value. So my XP is actually not going to be held on the character at all. It's going to be here in the game, in the player state, right? So, because it's fluid, it's something that can change. So here's my XP. I pull that in, and then what I want to do is I want to get that value. So get value. There it is. And that's, you can see the difference between these little 2 marks. One of them is a replicated value, XP, right, per player, and then a function parameter for add XP. That's the F on top of it, right? And what I want to do is add them together, right? So I want to say my current XP plus the value that I'm passing in, that new value that I'm passing in is going to be this thing, okay? And what I want to do is I want to set my XP as that. This is the way I'm adding it in. So I'm going to say, so I'm going to kind of pull this in. I'm going to use a setter this time. And when I set my XP, because XP itself is a replicated value, it's going to call instantly my onRepXP function. So my function is going to respond when my XP changes. That's what's going to happen. Okay. So why? Because we want to do something when XP changes. We want to broadcast that out. We want to update our user interface. We want to change the way the character looks. We want to whatever, right? Have a little sound that triggers, whatever it's going to happen, right? Okay. So that's the first thing that's going to happen. Okay. And then once we have that, then what we want to do is we want to call on XP change. We want to trigger that delegate and whatever that delegate's pointing to. Right now, that delegate's pointing to nothing. It doesn't point to anything. So this gives us a method of updating user interface. It gives us a method of updating a bunch of other stuff. Up till now, this is all we need to update the XP. We don't have to do the delegates. The delegates are there to help us with user interface, with animations, with all the other stuff that's going to be triggered outside of updating XP, right? So we can say, call, if we type the word call on XP changed. You can see that those events, when I use the word call in front of it, it only triggers the events that I created, because calling a function, it triggers the delegate, and whatever that delegate's pointing to. By the way, I could change what that delegate's pointing to as well dynamically if I really want to. So here's my on XP changed event. The other reason why I want to use delegates is because I can also test to see what kind of character it is. If it's an enemy, maybe the on XP changed event enemies, maybe they level up somehow too. As an example, maybe they level up because the character leveled up. That's crazy. I don't like that. But people do that all the time. Like example in Diablo, as soon as you level up, your world levels up. I don't like that type of game myself, but it does happen. So then what we want to do here is we want to pass this XP that we have into this function. Nope. I'm showing you the better way to do it. And that's why I'm showing you a way to, especially when it comes to user interface, it'll solve some problems later on, especially when it comes to things like your inventory system and that kind of stuff, because there's user interface involved and a bunch of other stuff. This helps with all that. So you don't have to do it that way. Is if you can make it work so that it replicates your, your properties and you can see them, I'm good. But this is definitely the better way. And this is how I would code it in C++ too. Okay. So now that I've called my XP changed event, sure, then I want to take my value and I want to print it out for now, right? So whatever that value is, I want to say that I got it. Now this is temporary. I'm not going to do this all the time. And so that's why I'm putting it into like this second part right here. I'm going to say, hey, my value, I want to use an append string function, this one right down here. And this append string, there's going to be three parts to it. I'm going to say I added, this is for debugging purposes, I added whatever I added. This is my value that I added, XP wise, right? So I added this much XP. So I can, right here, I can right click and add a pin, and then I can say XP, right? Added this much XP. And then once I've added it, I want to print it out. So I can print that string, print string, which is what I want to print. And this way it'll keep track of what I'm printing. Oops, what I'm printing. Okay, there we go. So that's the second part. Third part is I want to get a reference to the character and promote it to a variable because we're going to use that character in a bit. So the way to do this is to get the pawn, get pawn. So the get pawn function, it says returns the pawn controlled by this player state because player state controls a pawn. The pawn is actually being controlled by the player state. Just like the player controller is part of the, there's a relationship between the player controller and the pawn. And there's also a relationship between the player state and the pawn being the character in this case, but it could be other pawns too. Pawns that are not characters, they're just like simpler if you want to. So now we got that, we want to cast to BP underscore MP character, right? So once we can do that, if we can, that's a good thing. Then we want to save that character. Let's promote this to a variable, right? So we want to promote this to a character variable that we keep track of. So again, promote this to a variable. We call this character. So we have a reference to the character when we add XP. Okay, so here it is. And once we have that character, then we can use it later on, and we will for the dim. Well, it's a local variable, so let me just do that. Let me do that again. 1 second. I made that wrong. So again, promote to a local variable. I was thinking about that. I was like, that seems weird. What do I need that for? In the regular player state, I don't really need that. Okay, and then the last thing that I want to do is this big thing. Now it looks like a lot, but actually I've just partitioned this one to make it, instead of a big long line, I've kind of broken it up into a smaller line. So I want to get that character, and I want to get its character stats. So that's the next thing I want to do. Say, hey, character, let me get character stats. So get character stats. There we are. This is a struct, remember? All right. Notice the difference between a V, which is a local variable, an F, which is a parameter variable that's coming in from the function. These things, which means that this is a networked component. So character stats is a network component. I want to break that into its component struct, right? Here's our component struct. And what we care about is the next level. So I want to care about this next level XP. And what I want to do is I want to compare it to the XP that I've got right now. So I'm going to take XP. And I want to say if XP is greater than, right? If it's greater than the next the next level XP. Okay, if it's greater than that. By the way, when I made this diagram, I called it next level, but it's actually next level XP is what it should be. That was just my bad on the struct. Then if that's true, I don't need all this. I just need these ones. And by the way, if I go here, if I look here, you can actually hide pins, and so you only care about the pins that you see. So even though I've got all these pins here, if all I need is next level XP, I can hide the other pins. So I can hide walk speed and sprint speed and damage multiplier and stealth multiplier. So all I see is this, which can make it a lot neater to see than everything else. And I didn't do that here, but you can see that you can add in or show as many pins as you want. Okay. So you can also say hide unconnected pins, which does all that. right? So it does it all for you in one. So now that I've got that, I can branch. I can say, okay, well, let's branch. If that's true, if my XP is greater than the level that I need, the XP amount. So let's say I need 10 and I just got 12, then I level up. That's what I'm doing, right? So I want to grab this pin and put that over here. And drag that over here. And now let's make a little sequence node here. Now I don't have to do the sequence node. I'm just using it because it makes it easier for me to partition what I'm doing here. So first thing, I want to print a string that basically says I'm leveled up. That's what I want to do. So print string. Again, we can disable this debug thing. It's just for us to know that we've leveled up. You know, level up. And then once we've leveled up, we want to increment our character level. So character level, right? And I want to plus plus. Now, curious, if I did it this way, will the rep notify function trigger? That's the thing. Or should I say, should I do this differently? Should I say character level, you know, +1? So set character level to +1, and then do the setting manually. Do you think that the increment will work, as an example, across, you know, using the rep notify? That's a curious thing for you to think about. Because remember, the only time that rep notify is triggered is when I change the character level. Here, notice when we use a setter, if I just kind of grab in my a setter, it says with notify. But this one doesn't say with notify. So does that mean that this one won't notify you? We'll see that in a bit. So that's the first thing. So will I level up? Will I be notified if I just use the increment you know, operator? The other one is I want to update my character stats, because now that I've leveled up, so here's my character, and now that I level up, I can update my character stats. So update character stats, right? That's part of the character. There we go. And based on my character level, which is this, the new character level I just got. So here's my character level, right? That's another thing I want to do. So a couple things here. So when I level up, I increment my level, and then I update my character stats based on my level, right? And then the third thing I'm going to do is I'm going to broadcast that the character has leveled up, and that's that optional dispatcher that I want to use. And I say optional because, you know, Alex is asking, do I need to do that? Well, no, but it'll save you trouble if you do it this way. So if I want to do, sorry, character level is what I want to do, not character. Here's my character level, and I want to call on character level up, this one. And then what this does is it triggers whatever whatever the you know, thing that I'm connecting to. So what I mean is whatever this thing is pointing to. Okay. Right now this thing is not pointing to anything, so it's not going to do anything. But you'll see in a bit that it will point to something in the future. Okay. And just hang tight. You know, when we make our user interface, you'll see. So this is our add XP function. It looks like it's really complicated, but I've made it that way. I made it so that I've broken it up into parts. I could have made this one long line. And from a coding perspective, if I had this in C++, it wouldn't be that long, right? Literally, I would just say, like, you know, XP plus equals to value. That's what I would say. Call the XP changed event. So trigger the XP changed event, right? I would just click XP changed and pass in the XP value. And then the next line would be, okay, print that out. The next line would be, okay, get a reference to the character, right? That's like a one-liner, right, kind of thing. If I have a reference to the character, if that's cool, if the character exists, then go do something, you know, as an example. All right, so that's what this is. And now what I want to do is I want to use those two functions, on rep XP and on rep character level. That's these two things. So on rep XP, it's not doing anything right now. When the XP changes, what do I want to do? Well, the one I want to do is I also want to call this delegate right now. That's what I want to do. So I want to say XP, and then I want to call this on XP changed event. Call on XP changed event. Now you're going to say, wait a minute, aren't we calling this twice? You know, aren't we calling this thing twice? Because we're calling it once and we're calling it again, right? Because we're calling it here on XP changed event, but we're also calling it when we add XP, right? Right, so we're doing it here. Look, we're doing it here. And if I'm doing it here, but I'm also doing it in here, am I doing it twice? Right? Well, remember, what this is doing, the reason why I have it this way is because this does one thing and this does something else. Okay? And remember from a synchronization perspective what's going on, right? So you might think you don't need this, but I'll prove to you that you do. Okay? Next is on rep character level. So on rep character level is this one, and it's kind of the same thing. I want to get the character level, which is this one. And then all I want to do is want to call on character level up. So call on character level up. There we go, which calls the delegate. Again, this delegate doesn't point to anything right now, this dispatcher, but it will. Okay, compile and save. So right now there really isn't any way to test. I mean, I know that it's not broken if I start off everything and it's not doing anything. I have no way of testing whether the add XP function works, right? I can't level up. I don't have anything to level myself up with, right? So we need to create something to do that, and that's when we're going to add these pickups. Let's do that next. Then we'll take a short break after retesting. So I want to add coin pickups is what I want to do. So I want to make a new blueprint, and I want to call this new folder pickups. Here it is. So this kind of one thing goes with the other thing. I mean, I could have made the pickups first and then I could have made the XP second, but I kind of wanted to do it this way. So here's pickups. I want to make a new, pickup. It's an interactable of a type, but I want to make a new pickup, and it's going to be an actor type called base pickup. Okay, so let's do that. So we're going to make a new blueprint class of type actor. It's going to be called base pickup. Okay. And a couple things that I want to add in to this thing is, one thing is that we need to make sure that it replicates. So first thing we do is on the right where it says net load on client. What this means is that this object is going to load so we can see it on the client. And I want to make sure that it replicates. I'm going to click on check mark for this. Okay, so that's what it's going to do. Okay, compile and save. Next, once we know that it replicates, the entire thing replicates, then what I want to do is I want to add in a sphere collision component. So if I type in sphere collision, and this is my pickup radius, and I want to make this the default. So I'm going to drag it over the default scene route like so. Here's my pickup radius, and let's modify it. I want to change that the radius is 200, so sphere radius would be 200. Let's also give it a line thickness of 2, just so we can see it, and I also want to make it so that I can see it in game. So I don't want to hide it in game for now. Okay, so that's not part of the PowerPoint, but we've done this kind of stuff before. And it's also red, so we're going to see it as red. Next, what I want to also do is the collision category. I want to make sure that generate overlap is checked. It always is, but we should check it out anyway. So again, under pickup radius, if I go to my collision category, scroll down, you can see that the generate overlap events is checked. If it wasn't checked, then it wouldn't generate overlap events. Okay. Next, what I want to do is I want to add in a static mesh. So add static mesh, and we're going to call this pickup mesh, and we're going to give a default value for this. So the mesh that we're going to use is a coin. So it's actually called the coin mesh. So if I type in coin, you can see that there is a coin. This is it. And what I want to do is I want to change the scale of the coin to 2. So I'm going to just use this little lock button right here, which allows me to scale all the different components to 2. Right, compile and save. And once I have these components set to 2, I want to change this value to m_base, which is our base material. There it is. Okay, so it's really a basic thing that looks like this. Compile and save. Excellent. So that is the way it looks. One thing else we want to do is we want to make it so that the actual coin itself, a static mesh, has no collision. We're going to be able to pass right through it. So please change your collision presets to no collision. That's important. We don't want this thing to actually physically collide with the character in any way. Okay. And there we go. So that is our base pickup. What I want to do also now is I want to add in a variable of type integer called earned XP. So this is our basic, way of doing it. We're going to have a variable earned XP. We're going to make this of type integer, compile and save, and we're going to set the basic value of this base pickup. It's just a pickup to 1. Now, it could be any pickup. I can make this base pickup a sword instead of a coin. We're just using a coin just as a placeholder, right? It could be a a cube or whatever, right? Compile and save, because we're going to eventually not use this one. We're just going to test with this one. Okay, one thing also we want to do is make it so that it is instance editable, so we can see it. So the eye icon has to be on with this one. Next, I want to create the pickup method, so a function name pickup. That's what I want to do. And let's do that. So let's make a new function. We've done this before last semester. We made a function named pickup. Here it is. And the pickup function is going to have something called an owning character, which is of type BP underscore MP character. So that's the only one that can have a pickup right now. So again, owning character. Right? That's the owning character. By the way, it doesn't matter if you use a space here or not. It'll add a space in there for you, right? And then the type is going to be BP underscore MP character object reference. That's what that is. So we can assume that whatever the owning character is, it's a character that we're going to have in the game. Okay. Then what I want to do is I want to set the owner. So if I type in set owner, the beautiful thing about set owner is it basically sets the owner of an item. And we've seen this before from last semester as well. So we can say that the item, the person who owns this item, is our character. So that's something we can do. So you can say get owning character. We can, instead of drawing a line, I like to kind of put this. That's the way I like to code it. You could have drawn a line here as well, a wire. But you can see that we're going to use it in other places. I want to get the owning characters player state. So get player states. There it is. But the player state we're getting is a generic player state, and we need to cast this as cast to BP underscore MP player state, because we've made our own character state, right? Our player state, if you will. And that player state includes, XP and level. That's what it includes, those two stats that we're holding here on the character, as opposed to, having them somewhere else. Then I want to take that earned XP, this part, I want to get that earned XP, and I want to add XP from it. So I can get that, the player state from there, from this part, and I want to say add XP. There it is. There's the add XP function that comes from the player state, and I want to add in that earned XP. That's what it does. So it actually adds that value. Okay. And then after I've done that, I want to destroy the actor. So what this does is it takes away the coin. Okay, so this is what it is. So pickup, I set my owning character to own the coin. They own it right now. It becomes their coin to own, right? So no other person can have a reference to it. And then I get the player state relative to the owning character. I cast it as the custom player state we use. I call the add XP function that's part of that new blueprint. And then I add the earned XP on to the character, the player state. Because that player state is associated with a specific player, then that player will level up, okay, which is the way we're doing it. Okay, so it's kind of a series of connections or associations. All right, so that is the pickup function. Okay, the other thing we want to do is we want to make it so that we can respond to being picked up. How do I make it so it's picked up? So we're going to create a new function called, and I could have done this in the event graph, but I like, kind of doing this. So activate, I want to call a new function called activate pickup radius, I believe. If I can actually type it without the way I just did it. Pickup radius. There we go. Activate pickup radius. And I want to make sure that the other actor, and this other actor is of type actor, because it could be anything that's interacting, right? So not just the character. So we're going to say that other actor is the input, which is of type actor, actor object reference. Actor is anything. It could be the ground. It could be, another enemy or whatever, something else that's interacting with it. And we may want to make sure that the other actor is not the coin itself. It's not like, kind of somehow, overlapping with itself, which is possible. So other actor, right? we want to make sure that that is not equal to self. So we want to say that self is not what we want. We make sure that this is the thing. So this basically says, okay, you're overlapping with something, but it's not this, not the coin itself, or the thing. Then, if that's true, branch. So we're overlapping with something else. You know, the other actor is something else. Then what we want to say, let's try and cast that other actor to, okay, cast to BP underscore MP character, all right? So that's what we're trying to do. And if that's true, right, then what we can do is we can effect the pickup, right? If we can call pickup, right? So let's say pickup, that's the pickup function. And we can pass the owning character into the function. That's what it is. Now, we've talked about other ways of making custom objects, so collision objects. We could have done that as well, right? And so that way we wouldn't have to cast. I've talked about some optimizations when it comes to coding. We could have done it that way as well. But again, I'm keeping it simple for this one, and that's why I'm doing it the traditional way. Okay, so this is just activate pickup radius. Now we want to use the activate pickup radius here in the event graph. I'm just going to kind of kill all this for now. And the way this works is if I click on the pickup radius and on the bottom here, you can find that there is an on component begin overlap, this one. So when the pickup radius begins overlap, I want to call the activate pickup radius function on the other actor. That's what I want to do. That's all that is. So instead of it being here inside of the event graph, I've just squirreled it away instead of a function. Compile and save. Okay, so that's what this is. The next thing I want to do is I want to make the coin so it spins. We've seen this kind of thing before. We did this in, you know, last semester in the beginning, early in the last semester, and we did that for the pickups that we did, you know, kind of in our little drone game, right? So it's kind of the same idea. I want to have this pickup rotation. So in the event begin play, so again, event begin play, here it is. So here's event begin play. What I want to do is I want to have a little timeline, add timeline, and we're going to call this timeline pickup rotation. So this is pickup up here. Oh. Pickup rotation. There we go. Pickup rotation. We want to double click on this thing, double click, and we want to use add a track that's a float track. 5 seconds is fine. We want to loop that track. Definitely, so we're going to keep it looping forever. And I want to add in 2 points. 0, 0 is the first key. So this is 0 and 0. So at 0 time, it's at 0 degrees. The new track that I want to have is called rotation on the rotation Z. I forgot to do that, so I'm just renaming it here. And then I want to add another point, which is going to be 5 and 360. So at 5 seconds, that's what this is saying. That's the time. In 5 seconds, it's going to rotate 360 degrees. Okay, and we can see that by doing one of these. It's going to be a linear progression. I'm not making it a curve because that means it'll speed up and slow down and speed up and slow down. We don't want that. We just want a linear spin all the time, a constant spin. And so that's why it's just a line, you know, kind of a linear curve. Compile and save. So that's what this pickup rotation is, which gives us an output for rotate Z. And what we can do is we can set the actor rotation to that. So on update, set actor rotation, and we want to pass in, we want to split the struct pin, we want to pass in the rotation into the yaw. That's kind of on the Z axis. So that is uses a timeline instead of using the tick function to rotate stuff. And this is the better way to rotate things or change positions and do all those funky things. Using a timeline is way better. Okay, so that's that. And now let's add a BP based pickup to the game and test it out, see how it works. And then we'll take a short break. Okay, so back to the level. We don't need all of this. I can kind of hide all these things, right? And then I have a pickup here. It looks like a coin. Let's put this into the level here. We'll give a couple coins in the level, right? So we'll kind of add it in so that there's one for one player and one for another. We'll kind of duplicate this. There it is. So we have two pickups, base pickup 1 and base pickup 2. And then if I press play, this is where the magic happens. So what I want to do is I want to run over to my left pickup. Oh man, it's too high up. Let's try it again. Because the pickup radius is really small, and it should be, because it's like you're picking up a coin. So it's not something, unless you want to jump for it. You know, so I want to put it kind of lower down to the ground. And again, I can make it bob up and down too if you really want to. Like, those are all things we've done before. And let's try this again. So run over, and when I kind of go through it, boom, I get it, and I got 1 experience point. I want to come back to that. So let's check now, confirm that I actually got 1 experience point. So how do we do that? Well, we know that this is one character and the other one's another one. So if I type in character up here, we can see that there is characters here. So, but I also have the state. So if I type in states, you can see that I have 2 player states. I have player state 0 and player state 1. Okay, so let's first start with a character. So which character is this? Is this character 0 or character 1? I think it's character 1, and I'm right. So character 1 is the one that I have. It has stats. Here are the stats. If I looked at the stats themselves, here they are. There's the stats, right? Notice that I'm still my level 1 stats, right? It doesn't show me the level here. The level is held in the state, right? So state 1, this one. And if I look at the state, you know, as an example, and I want to look at the stats for the state. So did I expose that? I should expose it. This empty player state. Let's just make sure. And player state. Just want to look at that. And so experience. No. Let's make it so that we can see it. Sorry, it's my bad. Try that again. So we'll expose those. And then let's try it again. So again, this guy goes over and picks up the coin. And then I can look at my player state 1, and you can see that I've got XP 0 and character level 1. And then what about player state 0? Player state 0 has XP 1 and character level 1. So this is interesting. So MP player state 0, okay, and this is my character, right, as an example. So if I go to player state, so character 0, character 0 is this one, but character 0 is associated with game state 1. Okay, that's one thing to note, and I wanted to show you this so you don't get confused. Just because the numbers are there, they get instantiated when the server wants to instantiate them, but they're each associated with their own character state. So it could be confusing, but I wanted to show you this. So character 0 is the blue character, right? But game state 0, right? Game state 0 refers to, you know, the red character, because that's the one that got this thing. And to prove this, state 1 has 0. Let's see what happens when I move my other character around. This one. Okay, so there's my other character, and I want to move this one, so he's going to pick up the coin now, or she is. Right, so there we are. Just run, and pick up the coin, pick up 1, and you can see now that, you know, player state 1 is also 1. Okay, so you can see that, right? So both of them, player state 1 is 1, and then player state 0 is also 1. So it keeps track of the XP right here. And this is where we keep track of the XP. We keep track of anything volatile like this, as an example, in the game state. Okay, we keep track of stats, which don't change very often, in the player. Okay, and it's this separation of concerns that gives us some, you know, the ability for us to be more flexible. And also, I wanted to talk about game state with you because we haven't talked about that yet so far over 2 semesters, and you need to know how that's used. Okay, that's it for right now. Let's take a short break. We're sitting at 4:41, right? And this is a great place to take a 10-minute break. When we come back, after I have some coffee or whatever, we'll soldier on and finish this off. I don't want to take it the entire you know, time. We should be able to finish a little early if I'm right. Okay, let's take 10 minutes. I'll stop recording now.